Today we're going to start an introduction on probability, but to do that we have to start with combinatorics and the counting principle. And what the counting principle talks about is it says if there are A ways to do one activity and B ways to do another, then there are A times B ways for both to occur. So if I have an example like this where Joe needs a suit and a tie, and we know that the suit comes in black or blue and is made of silk or wool, and the tie is either striped or solid, how many different selections can he make? Well, we know we have two possibilities for the color, and then we have fabric, also two possibilities, and then a tie that's either striped or solid, two possibilities. So when I multiply those together, I have 8 different ways I can make that suit up. Another way to do this is to do a diagram where you have a blue suit or a black suit, and then off of that I could wear a blue suit and either a silk or a wool and a silk or a wool, and then from that blue silk suit I could either go solid or stripe, solid or stripe, solid or stripe, and then solid or stripe. And what this has done, this is kind of called a tree diagram. It gives us all the different possibilities. So for instance, this is a blue wool suit with a solid tie, and you can see at the end of this I have 1, 2, 3, 4, 5, 6, 7, 8 choices. If I go through and list all the different possibilities, it's called a sample space. Let's take a look at a couple other examples. I want to know how many different 6-space license plates can be made with 3 letters in the first 3 spaces and 3 numbers in the second 3 spaces. So to do this problem, I would list my 6 spaces out and then start popping numbers in for each possible choice. Now it says nothing about letters or numbers being repeated or not repeated. So if they don't say anything, you can assume they're repeats. So if I have letters in my first 3, I could have 26 in my first, 26 possibilities in my second, and 26 possibilities in my third, if those are all letters. For numbers, I have the numbers, if it's a single digit, I have single digits of 0 through 9, so that's 10 different numbers. Now again, these are the possibilities that could go into each space. So then I multiply that all out to get my answer. These get rather large, so this is, for instance, a total of 17,576,000, and like I said, they get large. This one's smaller. You've got a guy wanting to fish, choice of 5 poles, 4 lines, 43 lures. How many different setups can he make? Again, take 5 times 4 times 43, and we get done. So this is going to be 960. Both of these would not be the best to diagram out because there's just too many possibilities, but in small senses we can diagram it out and see all of our choices. In order to do combinatorics and probability, we need to know what a factorial is. Factorial is basically this exclamation point looking thing, And what a factorial is it's always given in terms of a non-negative number, and by this value with a exclamation point. And what it is the product of all the positive integers less than or equal to that value. So 5 factorial is 5 times 4 times 3 times 2 times 1. Okay? 3 factorial is 3 times 2 times 1. Now, we need to talk about permutations, which is basically all the different arrangements you can make where order is important. So we talked about earlier doing license plates, and when we talk about license plates, the order of those letters and numbers matter because it identifies a different vehicle. Now there's a calculator notation we can use to do this, and I've seen different calculators with different notations. So NPR or P comma NR is a way to notate a permutation. And what it talks about is it's where you have n total number of objects and you want to arrange r of them, or choose r of them to arrange. And the calculation for that is n factorial over n minus r factorial. Your calculator will actually do this. You don't need to memorize it, and I won't hold you accountable to memorize it. And I'll show you how to do that in a second, but let me give you an example of how to do this. Now, there are a couple of ways you can do this. Sometimes I don't even use that formula to do these problems, because if I want to arrange 4 different books on a shelf and I look at my shelf, I know I have 4 slots I can put these books. And if I say, okay, well, in this first slot, how many choices do I have to put books down? Well, I have 4 different choices. And then in the next slot, so I'm basically taking this as 4 different events and using a counting principle. In the next slot, since I've already put 1 book down, I only have 3 slots to use, and I'm going to have 3 choices for that slot. Next one, I got 2 slots, so for this one specifically, 2 books in my hand, I could put either one of 2 books here. In the last one I have 1, so this is 12, 24 total. Now the other way to do this is say, well, I have 4 items, and I want to arrange, which is my P, all 4. So this would be 4P4. Now let's do this on a calculator. So what I do is I hit my 4, go to math. Right here it says probability. I'm going to move over to that. There's my P, NPR. So I'm going to hit number 2. That comes up, and I'm going to hit 4. And hopefully when I press enter, I get 24. Sure enough, there it is. Alright, so there's a couple of ways to notate that. This is also 24. Again, I usually go over here, but I'll do both. So we've got 32 ski club members, and we want to know how many ways we can select a president and a vice president. Now, order is going to matter because the president has a higher ranking than the other, so this is why order matters. So what I'm going to do is I'm going to say I have 2 people to select, and if I look at all the members, for the president and then the vice, since there are titles associated, the order is going to matter. I have 32 choices for this guy. And then on this guy, since I've already picked my president, I have 31 choices left. So if I multiply 32 times 31, I get 992. Now how do we do this with permutation notation? I have 32 to pick from, and I'm going to arrange them from 2 people picked. So I go 32P2, go to the calculator, 32, go to the probability once again. Whoops. Let's try it again a little slow. go to the probability and hit 2, enter. There's my 992. So now we're going to take a 3-digit number formed with the numbers 1 through 7. I don't get to repeat numbers at all. And I want to know how many 3-digit numbers will have values between 100 and 500. This is a little bit different. So if I want a value between 100 and 500, I don't necessarily do this with permutation notation, although you can. Not a big deal. One thing I need to know is I need to know what number I'm going to start with. So if I can go all the way up to 500, you could say, well, you can use a 5 here, but in actuality you can't, because the numbers you have left are not zeros. And even so, there are no repetitions. So if I did have a 0 and I could put a 0 here, all right, any other number I used would pop me over 500. So no way can I do that. So I can't use a 5 to start. I certainly can't use a 6 or a 7, because then I'd be over 500. So I really only have 4 choices in the first problem. Then for the second number, I can basically pick anything, because if I start with a 1, anything thereafter that I use is going to be over 100. So I can use any of my remaining numbers. Since I've already used 1, I only have 6 to choose from. So I can use 6 numbers here. And then finally, I can use any remaining number for this last term. All right, but I've already used 2, so I only have 5 more. So I get 120 on this. Now, permutation-wise, you still have to start with 4, because you only have 4 choices for the first one, but then you could say 6p2 and still get the same thing. Let me show you. So we wanted to go 4 times, and I usually put anything that's got multiple terms in it in parentheses. 6 p 2, close those parentheses off, and you know 120. So there are multiple ways to do a lot of these problems. I tend to, in permutations, at least when they're small and I can figure them out, use this more of a counting principle method to get there. Now, combinations. This is a little bit different than a permutation. A combination is an arrangement of things, but the order is not important. So rather than an arrangement, I like calling these groups, because a group is just a cluster of things, and it's not a line, it's not an arrangement, it's not like a seating chart. There's not anything important about how you view them. And again, this has a similar calculator notation, NCR. C stands for combinations, all right, and it has a little bit different equation. It's n factorial over n minus r factorial, just like the permutation, but you include divided by r factorial. So since we're dividing by another number, that assumes that there are less combinations than permutations. Let me show you why. So if I take the letters A, B, C and I arrange them in a line, I can arrange them 6 different ways. And I would take the calculation of 6 or 3p3 and get a total of 6 from that. If I take the letters A, B, C and put the 3 letters into a group, these are all groups of those 3 letters, but in that group, if I don't concern myself with the arrangement of the 3 letters, those 3 letters are in the group regardless of the arrangement they're in. So There's only one combination of these three letters. If I go 3C3, then I only get one. And we can prove that on the calculator. Let's just go ahead and do that. So I say 3, hit math. Again, go to probability. Here's C right under P. And 3, hit enter, and there's my 1. So order and non-order are going to be very important for these different types of items. Let's go through a couple examples. How many different committees? Okay, so a committee is a group of people, and as I said before, combinations are more like groups. 5 people can be chosen from 10 people. So this is really from these 10 people, I'm going to choose 5. And if I put this in a calculator, this is really hard to diagram out, as you can imagine. So I just go ahead and use a calculator for all these combinations. So I say 10, hit my math, probability, hit that 3, and I want to choose from 5 people, and I get 252. So here we go. You got 6 friends and they want to play enough games of chess to be sure that everyone plays everybody else, and you want to know how many games they're going to play. So in this problem, we're taking from 6 people, and since only 2 people can play chess at a time, we're picking 2. So we hit 6C2. And we get 15 different games. Now, one of the things you need to know is this combination method, combinations take out all repeats. So in the case where I showed you earlier, when we had our example, these are all repeated groups, right? And the combination calculation takes all those guys out. So let's move to our next example. We want to determine whether each of these is either a permutation or if it's a combination. So we want to select 3 students to attend a conference in Washington, D.C. There's no hierarchy, there's no specific titles for these kids, so we're basically picking a group of 3. This is a combination. Selecting a lead and an understudy for a play. There's certainly titles associated with these 2, so order is going to matter. So this is a permutation. Assigning students their seats on the first day of school. This is more than just a general grouping because there is order to the seats, so this is also a permutation. This problem is a little bit more difficult. This is going to involve not only grouping, but a actual counting principle as well. 2 different events are going to happen. So let's read this. There's 14 juniors, 23 seniors in a service club. The club is to send 4 representatives to the state conference. But it asks, how many different ways are there to select groups of 4 to attend? We add these up. We have 14, 23, total of 37. We're going to choose 4. That's totally straightforward. So if I go 37, choose 4, not a problem. Go to my calculator, shoot on over to probability, get a fairly large number, 66,045. But now is the harder part of this problem. Now they decide, rather than just choosing 4 kids, they want to make sure things are kind of equal, and they represent 2 juniors and 2 seniors. How many different groups are possible? So what we really have to do is we have to have 2 events. Event 1 and then event 2. This is going to be choosing a group of juniors and then choosing a group of seniors. So in order to choose a group of juniors, we have to ensure that we get a junior. So I can't pick from 37. I have to take from my 14 to ensure a junior, and I only get to pick 2 of them. Then, to ensure a senior, I have to pick from my 23 seniors, and again I have to pick 2 of them. 2 different events, this many ways to do the juniors, this many ways to do the seniors, multiply together to get my total of different ways. So we can do this on our calculator as well. Make sure you use parentheses. We go 14 C2 and 23 C2. Multiply those guys together and we end up with 23,023 ways. So the last one is a little more difficult. The big deal about today was A, making sure you understand what a counting principle is. Lots of different choices, multiply them together, and then understanding the difference between permutations and combinations is basically order and non-order. So that's it. Know my math lab, and make sure you just take your notes and get ready for tomorrow.